this session, we shall deal with some methods of differentiation. The very first model is usage of very first principle, that is limit as h tends to 0 f of x plus h minus f of x by h as h tends to 0. That is quite clear, and we could have applied it so many cases and everybody knows about it. And then usage of product rule, usage of quotient rule, and so on. And later on, function of function method. Yes, you observe the function y is equal to ax square plus bx plus c whole to the power of m. In this, two functions are there, f of x equal to x power m, g of x is equal to ax square plus bx plus c. Actually speaking, f of g of x is nothing but ax square plus bx plus c. So, function of a function. Well, irrespective of the theoretical consideration or any other thing, let us now recall the working rule, which is very habituated to us and which is we feel easy, is dy by dx is equal to, consider this as some x, it looks like x to the power of m, its derivative is m into x to the power of m minus 1. Immediately, you are supposed to find the derivative of that expression which you have supposed it to be some x. What is that x? Ax square plus bx plus c. Therefore, div into dy dx of ax square plus bx plus c. This is again m into ax square plus bx plus c whole to the power of m minus 1 into ax square to ax plus bx, it is b. For c it is 0. Hence, the total derivative is m into ax square plus bx plus c whole to the power of m minus 1 into 2ax plus b. And as we could just discuss, it is very easy and we are habituated with it. We are acquainted with this very much. As let us now find the derivatives of certain functions with this principle. Y is equal to root of x square plus 1. What is its derivative? Dy by dx is therefore equal to, the things must be done very quickly. I have supposing this to be some x. Root x, what is the derivative? 1 by 2 root x into derivative of this 2x, cancel 2, so that it is x by root of x square plus 1, that is x by y. The answer is x by y. Again, observe one more function, y is equal to x plus root of x square plus 1. What will be the derivative? Dy by dx is therefore equal to, derivative of x is 1 plus root of x square plus 1 is x by root x square plus 1 as before. Hence, it is root of x square plus 1 plus x by root of x square plus 1. Hence, it is just nothing but y by root x square plus 1. This is what to say about dy by dx. Dy by dx. Now, one more function. Y is equal to x plus root of x square plus a square whole to the power of n. You observe the series of problems with which I have started. The first problem is root x square plus 1, next x plus root x square plus 1, next x plus etc. This you could have had y by root x square plus 1, and this here we have ny by root of x square plus a square. These are the things to be recollected or remembered. You need not put all these steps. Such a famous item is easy to remember. Okay, let us observe its proof. Dy by dx is equal to n into x plus root of x square plus a square whole to the power of n minus 1, 1 plus x by root x square plus a square. Okay, this is n into x plus root of x square plus a square whole to the power of n by x plus root of x square plus a square whole to the power of 1 into root x square plus a square plus x by root of x square plus a square. You tell me what is going to happen. That will be going to be cancelled. N into what is x plus root of x square plus a square? It is y. So it is ny by root of x square plus a square. X square plus a square. Let us now make use of a general understanding. You can observe the style of doing these problems. If we find the derivative of a particular function, we may have to think of the different cases in which it can be reused. What are all the consequences? If you think of such things at a time and keep them as a packet in your mind, they can be readily be used. Yes, it is easy to remember also. Therefore, y is equal to x plus root of x square plus or minus a square whole to the power of n implies dy by dx is equal to ny by root of x square plus or minus a square. Well, it is an easy matter, of course, to reuse the same concept here also. F is equal to log mod x plus root of x square plus a square. Then what happens to it? What is dy by dx? Dy by dx is equal to log of this is 1 by x plus root of x square plus a square into as x plus root of x square plus a square. Here you put n 1. What has happened? Y by root of x square plus a square, isn't it? So it is y by root of x square plus a square. What is y? Actually x plus root of x square plus a square. That is x plus root of x square plus a square. This and this are going to be cancelled, leaving you dy by dx is therefore equal to 1 by root of x square plus or minus a square. So it is quite possible to reuse this answer there, and these are very famous derivatives. X plus root of x square plus a square, x plus root of x square minus a square, and which has been included in a logarithm, log of x plus root of x square plus a square, log of x plus root of x square minus a square, and you must be able to say the answer as and when they are required. Such a famous things they are. Well then. Next one, y is equal to sine square of ax plus b. Is how many functions are there? 1, 2 or 3? 3 functions are there. Whole square sine of ax plus b. Well, let us find the derivatives one by one in an order, so that it is dy by dx is therefore equal to 2 sine of ax plus b, thinking sine ax plus b as x. Now it looks like x square, derivative is 2x, and then ax plus b. Sin x, it is cos x, that is cos of ax plus b, into for ax plus b it is a. Altogether that is 2 sin theta cos theta is nothing but sine of 2 into theta. A. That is the derivative. This is another simple example of a function which looks like function of a function. Next model, parametric differentiation. Besides the dependent variable y and independent variable x, there has been another letter, namely parameter, which is the direct symbol or the representative of the family of curves in which x and y are involved, of course. How do they look? How does they look? Let us see. X is equal to 80 square and y is equal to 280. Find dy by dx. Find dy by dx. X is a function of t, y is a function of t. What is dy by dx, derivative of y with respect to x? How can you say? First of all, dy by dt. What is dy by dt? Thinking t as the independent variable, the derivative is 2a. And dx by dt. Now here we treat t as the independent variable and x as the dependent variable. So that here is square. What is the derivative? 280. But we want to have dy by dx. Dy by dx is therefore dy by dt by dx by dt. It's nothing but 1 by t. 1 by t. Yes. What is the use of these parameters actually? As and when the main equation of a curve looks very bulkier or brisk, we use such parameters so that the process of differentiation may become easier. X plus y is equal to t and x minus y is equal to 1 by. Then dy by dx is equal to. In the previous case, we were given x and y individually. But here we are given as an implicit function. In a combination they have been given. Well, we want to have dy by dx. How to multiply, how to eliminate the unknown thing here? You see, it's very simple. You just multiply them. X plus y into x minus y is equal to t into 1 by t is 1. Therefore, x square minus y square is equal to 1. If you differentiate on both the sides, 2x minus 2y dy by dx is therefore equal to 0. If you cancel 2, what is dy by dx? Dy by dx is therefore equal to x by y. So according to the scene and situation, according to the data and necessity, you are supposed to make your move. Yes, you have to get your strategy. You have to put your strategy as next one. X is equal to sine theta plus cos theta and y is equal to sine theta minus cos theta. Then dy by dx is equal to. You first of all observe the options. Is the answer given in terms of thetas or x's? In what way it is given? Suppose in terms of thetas, if you want to have the answer, it is dy by d theta by dx by d theta. Dy by d theta is nothing but cos theta plus sin theta by cos theta minus sin theta. Cos theta minus sin theta. No, couldn't follow. Shall I explain it once again? Dy by dx is therefore equal to, what is dy by dx? It's nothing but dy by d theta into 1 by dx by d theta. What is dy by d theta? Derivative of sin theta is cos theta, derivative of minus cos theta is plus sin theta by cos theta minus sin theta. If you want to express it in terms of x's and y's, so you can do, why not? What is sin theta plus cos theta? It is x. What is cos theta minus sin theta? It is minus y. Therefore, you can have the answer both in terms of thetas and x's also. Suppose in the options given only x's and y's are present, then you can think of this procedure in another way also. What the way is? X square plus y square is equal to, that is, I am eliminating theta. I am interested to eliminate theta. How to get that idea? The question is, what is dy by dx? and among the options no theta is present. In every option x or y is present. Then and there itself I would have got the idea of eliminating theta. Well, what is x square plus y square? Sin theta plus cos theta whole square plus sin theta minus cos theta whole square. It looks like a plus b whole square plus a minus b whole square. That is 2 into a square plus b square. That is 2 into sin square theta plus cos square theta is 2. The direct differentiate it on both sides. 2x plus 2y dy by dx. 2y into dy by dx is equal to 0. You can cancel 2. dy by dx is therefore equal to minus x by y. The same thing we could have had in the previous case also. Yes, of course. So it is minus x by y. So that is why according to the necessity, according to the situation, you have to fix the plane of thinking and the strategy to put. X is equal to log t and y is equal to e power t. dy by dx is therefore equal to, what is dy by dx? You need not put any step. You must be in a position to have the answer immediately. What is that? Derivative of y with respect to t by derivative of x with respect to t. What is it? E power t by 1 by t. It is nothing but t e power t. T into e power t. Okay, just like that. Let me give you one more such problem. X is equal to e power theta plus e power minus theta. Y is equal to e power theta minus e power minus theta. Then dy by dx is equal to. Then dy by dx is equal to. How can you do that? How can you do that? X is equal to e power theta plus e power minus theta. Y is equal to e power theta minus e power minus theta. If you proceed systematically, then dx by d theta is e power theta minus e power minus theta. Dy by d theta is e power theta plus e power minus theta. Isn't it? Okay. dy by dx is, what is this derivative? E power theta plus e power minus theta by dx by d theta. E power theta minus e power minus theta. This is x, this is y. Hence the answer is x by y. The answer is x by y. What is dy by d theta? E power theta minus of minus plus e power minus theta. What is dx by d theta? E power theta minus e power minus theta. Another way of obtaining that result is like this also. You just consider x square minus y square. What is it? What is it? What is x square minus y square? A plus b whole square minus a minus b whole square. What is that? 4ab. That is 4 into e power theta into e power minus theta is just nothing but 4. Therefore, 2x into dy by dx minus 2y into dy by dx is therefore equal to 0. You can cancel 2, so that therefore dy by dx is directly, it is x by y. How can you get this idea? Look at the options. Is the answer expressed in terms of thetas or x's and y's? You observe that and choose the strategy that you have to play. Choose the plan that you have to work so that dy by dx is x by y. Either in that way or in this way you can have the answer. So elimination of that parameter also plays a major role in finding the derivative immediately. Yes. After noting down the parametric differentiation, let us now switch over to another type of differentiation, namely implicit function differentiation. What is that? What do you mean by implicit function? It is the exact opposite word of explicit nature. He is a man of explicit thoughts. What does it mean? He is very clear in his expression. He can say, he says what he likes to say immediately, like that. He is very clear. He is a man of implicit thoughts, means he cannot be understood directly. He cannot be understood. He always likes to speak in indirect words, like that. Such type of word, implicit, has been named after for these functions. What does it mean? So, the dependent variable and the independent variable cannot be separated. They will be binded over in a particular relation. You cannot get y out. What I mean to say is, look here, x square plus x cube y plus 3xy square plus 4y cube is equal to 0. Find y. I'm sorry. Can you find y? Y is equal to, can you express it? On the right hand side, no y must be present. Single y must be present in the left hand side. Is it possible to express y as a function of x directly from this equation? Is it possible or not? Let us think of that concept later. Is it very difficult or not? Yes, it is absolutely very difficult to get y as a function of x clearly. This is said to be an implicit function of x and y. Of course, there has been a long procedure in our general methodology. But you see, in the case of competitive examinations, we shall use one more methodology. You see, let me call this f of xy. It has been given dy by dx is equal to minus dou f by dou x by dou f by dou y. Let us get acquainted with this symbolism. What is meant by dou f by dou x? What is meant by dou f by dou y? They are just nothing but the partial derivatives. As in when you observe more than one variable at an instant, in a particular function, keeping one variable only in our mind and keeping all the other things as constants, you differentiate. That differentiation is called the partial differentiation with respect to that particular variable. This is also symbolized as minus fx by fy. Fx is nothing but the partial derivative of f with respect to x. Fy is nothing but the partial derivative of f with respect to y. Well, let us find that one here. dy by dx is equal to, what is that? Minus, what is the derivative with respect to x? X square, 2x. Y, constant, 3x square y. Y square, constant. For 3x it is 3. 3 into y square, 3y square. Y cube is a constant, 4 is a constant, 4y cube is a constant, its derivative is 0. So, in numerator, we could have put the derivative of that f of xy keeping y as constant. Now, dou f by dou y. Now, you repeat the same by keeping y as constant. Derivative of x cube, x square, 0. X cube is constant. For y, it is 1. 3x is constant. For x, for y square, it is 2y. 4y cube, 12y square. This is the derivative of y with respect to x. For obtaining this formula, Euler's theorem, Euler's result, and some more other things are also used here, which is beyond the scope of the time of this class. Not beyond the scope of the subject, but it is beyond the scope of the time of this class. Okay, like this we find dy by dx for implicit functions. Let us observe some more derivatives of some more implicit functions. Suppose xy into x plus y is equal to 2 has been given, and he has asked us to find dy by dx. How to get it? You first of all convert this as an equation. X square y plus xy square minus 2 is equal to 0. Call this f of x comma y. As usual, dy by dx is equal to minus fx by fy. That is equal to minus of what is the derivative by keeping x as the only variable present there. For x square it is 2x, 2x into y, 2xy. Y square is a constant, for x it is 1, hence it is y square. For minus 2 it is 0 by derivative of f with respect to y, partial derivative with respect to y. So you are supposed to keep x as constant. X square is a constant, and for y it is 1, so it is x square. X is a constant, for y square it is 2y, so it is 2xy minus 2k. For minus 2 it is 0. That's all the answer. You can still simplify that. That is minus of y into y plus 2x is the numerator, and x into x plus 2y is the denominator. So that you can write this as minus y into 2x plus y that is the answer. That is the answer. Well, next one more function. What is dy by dx? That is the question. Root x by y plus root y by x is equal to 2. What is dy by dx? He is asking us. Oh, it looks bulkier. It's not convenient. It's not pleasant to look at. Okay, we can change the fate and shape of the problem. Of course, by squaring it on both the sides. You just square it on both sides. What is going to happen? X by y plus y by x plus 2 is equal to 4, isn't it? That is x square plus y square by xy is equal to 2. That is x square plus y square is equal to 2xy. That is x minus y whole square is equal to 0, or y is equal to x. dy by dx is therefore 1. How simple it is. You must be able to answer this. You get that idea. It looks like a plus b, a square plus b square plus 2ab. ab terms will go away. Only 2 will be remained here. So that plus 2 goes the side, becomes 2. Take the LCM. X square plus y square by xy is equal to 2. That is x square plus y square is equal to 2xy. X square plus y square minus 2xy is equal to 0. That is x minus y whole square is equal to 0. That is x minus y is equal to 0. That is y is equal to x. Thereby dy by dx is therefore 1. dy by dx is therefore 1. Yes. One more thing. Y is equal to sin x plus cos x by even though it is not an implicit function, it looks like a bulkier problem, but it is so simple as such. How? You just expand the denominator. What is in the denominator? 1 plus sin 2x is there. You can write 1 as cos x plus cos square x plus sin square x. Sin 2x as 2 sin x cos x. So it can be taken as cos x plus sin x whole square. Under root it is plus or minus of cos x plus sin x. At most it is plus or minus 1. If it is cos x plus sin x, it is 1. If it is minus of cos x plus sin x, it is minus 1. Whatever it might be, y is equal to plus or minus 1. Of course, if he gives the domain of x, then we will be able to decide. It is immaterial. We do not like to have y, but we want to have dy by dx. Hence, dy by dx is therefore 0. Dy by dx is therefore 0. Another standard problem comes to us. Let us receive it very carefully. Root of 1 minus x square plus root of 1 minus y square is equal to a into x minus y. What is dy by dx? Of course, by putting a beautiful substitution like x is equal to sine alpha and y is equal to sine beta, x is equal to sine alpha and y is equal to sine beta, then it is root of 1 minus sine square alpha plus root of 1 minus sine square beta is equal to a into sine alpha minus sine beta. Then dy by dx is therefore equal to, it is a famous problem, it is root of 1 minus y square by root of 1 minus x square. That is what I mean to say is you may have to remember the answer. Such a famous and useful result it is. Dy by dx is equal to root of 1 minus y square by 1 minus x square. Well done. The next procedure that we may have to recall or remember is logarithmic differentiation. As and when the given function f of x or y is so bulkier, involved as a product and quotients of so many functions or variables in the exponents place like that, if you have, then logarithmic differentiation, process of logarithmic differentiation is under use. As an example, you observe this, y is equal to x minus 1 whole square into 2x plus 3 whole cube into 5 minus 6 7x square whole to the power of minus 4 by 2x minus 7 whole to the power of 5 into x plus 1 whole to the power of 9. What type of formula do you like to use? U by V or U V W by P Q? Is it a joke? It is not so easy if you proceed systematically. Then we use logarithmic differentiation, that is, you take logarithms on both the sides. Log y is equal to log of m by n, log m minus log n. Again, log of a, b, c, log a plus log b plus log c. Again, log a is 2 log x minus 1, like that, so that you can have 2 log x minus 1, 3 log 2x plus 3, minus 4 log 5 minus 7x square, plus 5, no, minus, as it is in the denominator, minus 5 log 2x minus 7, minus 9 log x plus 1. Minus 9 log x plus 1. Now you find the derivative, log y. What is derivative of log y? 1 by y into dy by dx is therefore equal to 1 by y into dy by dx is therefore equal to, what is that? 2 into, for log x minus 1 it is x minus 1, for x minus 1 it is 1, plus 3 by 2x plus 3 into, for 2x plus 3 it is 2. 4 by 5 minus 7x square into, for 5 minus 7x square it is minus 14x, minus 5 by 2x minus 7 into, for 2x minus 1 it is 2, minus 9 by x plus 1. And by getting it simplified, you will be able to have a lengthier answer. Of course, nobody can save it. Its nature is like that. Nobody can save it. So ultimately the answer is dy by dx is equal to y into, y means this bulkier expression, into 2 by x minus 1 plus 6 by 2x plus 3 plus 56x by 5 minus 7x square minus 10 by 2x minus 7 minus 9 by x plus 1 is of course the answer. Bulkier problem, lengthier answer, its fate is like that. Nobody can save it. Okay, one more such thing we observe. X plus y whole to the power of m plus n is equal to x power m into y power n. That is a beautiful concept. X plus y whole to the power of m plus n is equal to x power m into y power n. It is an implicit function of x and y provided logarithmic differentiation is inevitable there. Therefore, we use logarithms on both the sides. M plus n into log x plus y is equal to m log x plus n log y, and then by differentiating, after that you will be going to get the answer, as it is a famous answer, please. Dy by dx is equal to y by x. Let me illustrate this. X plus y whole cube is equal to x square y. M plus n is 3. What is dy by dx? Y by x. X plus y whole to the power of 10 is equal to x power 7 into y cube. What is dy by dx? Y by x. X plus y whole to the power of 15 is equal to x power 8 into y power 7. Again, m is 8, n is 7, m plus n is 8, so that dy by dx is equal to x plus y. X plus y. Like that we have the answer. So it is a beautiful mold. The reusability of the result can be observed here, surely. And it can easily be verified if you can proceed, no problem about that. As next one, what is the procedure? Of course, we could have had the answer as a formula in the beginning itself. Of course, derivative of x power x is x power x into 1 plus log x. How is it true? We are taking logarithms on both sides. Log y, derivative is 1 by y into y dash. Y dash, I mean dy by dx is equal to u v. U derivative into v plus v derivative into u. So y dash is equal to y into 1 plus log x. That is x power x into 1 plus log x. Into 1 plus log x. Basing on this result, we produce a pattern in our mind that dy by dx is equal to y into, it is compulsory, y into, it is compulsory, and if you take logarithms here, it becomes x log sin x, x log sin x whole dash. And of course, by making uv formula in the use, you can be able to have, you will be able to have the derivative. How? It's very simple. It is nothing but y into u derivative into log sin x plus derivative of log sin x. For log sin x, it is 1 by sin x, and for sin x, it is cos x. This is v derivative into u. This is therefore y into log sin x plus x cot x. X cot x, that's all. What is y? Sin x whole power x. Even for this also, there has been designed a beautiful procedure also. Of course, most of the students, almost 90% of the students are show much interest to follow this method. There has been another method also that also is flexible, very easy to follow. Let us have a look over that. I do not rub this up. Let this answer be like here only, like this only. Y is equal to sin x power x. You split this into two forms. You first of all suppose this base has some k. Then you take the exponent as some constant, it is sin x power a. dy by dx is equal to derivative of k power x is k power x into log k, isn't it? That is k power x means sin x power x into log sin x plus for this. What is the derivative of sin x whole power a? A into means x into sin x whole power x minus 1 into sin x. For sin x it is cos x. Another way of getting the answer. Do you believe that these two answers are one and the same? Why not? It is y into log sin x, y into log sin x. You see, sin x whole power x minus 1. What do you mean by that? Sin x whole power x by sin x whole power 1. Sin x whole power 1 cos x by sin x is cot x cot x. So y into x cot x. Yes, you have. These are one and the same. Okay. See, in some problems you look that is easier, in some problem you may look this is easier. Whatever procedure you like to have, you can. Yes, this is the way to get the answer. You see, in this logarithmic differentiation, there are some brisk problems you may at which you may get bored. Let me give you one such example. Even at that situation also, we shall be making use of this procedure so as to simplify the style of obtaining the derivative. How can it be done? We shall see. Y is equal to sin x power cos x plus log x power tan x. What is dy by dx? If you can you apply logarithms directly to this y? Simply not. Why? Because it is a sum of two functions. Log of f of x plus g of x can never be simplified. It lies and dies like that. It is log of f of x plus g of x. If at all it looks like f of x into g of x, log of f of x into g of x can be taken as log of f of x plus log of g of x. So it's not possible. So you have to separately consider this as u, this as v, and by differentiating. But you see, in this process, we can have the derivative directly. Well, how to tackle with this problem? Look here. First of all, base as constant. Next, exponent as constant. Just like that, base as constant, exponent as constant. What is its derivative? A power cos x. A power cos x into log a into minus sin x. Am I right? For a power cos x, it is a power cos x into log a. For cos x, it is minus sin x plus sin x whole power b. b into sin x whole to the power of b minus 1 into cos x. First part is over. Next part. For c power tan x, c power tan x into log c into, for tan x it is secant square x. C power tan x into log c into, for tan x it is secant square x, plus for log x whole power d, d into log x whole to the power of d minus 1 into, for log x it is 1 by x. Now let us replace a, b, c and d by their parental functions. What is a? Sin x. Sin x power cos x into log sin x into minus sin x. What is b? What is b? Cos x. Cos x into sin x power cos x whole power minus 1 into cos x. What is c? Is log x. Log x whole power tan x into log of log x into secant square x. What is d? D is nothing but tan x. Tan x into log x whole power tan x minus 1 into 1 by x. My dear friend, you please do not get bored about the length of the answer. Its fate is like that. You believe in one thing. Are we able to trace the answer immediately or not without any other extra steps or considerations? That is a beautiful thing here in this process. So here we have used our own technique. This is the way in which the derivative of sum of two functions which occurs as function power another function. It is a tedious job, you see. Of course, it can be simplified in this way. This gives you the answer. And according to the options available, you get the answer simplified so as to get the required. Yes. One more thing about this. X power y plus y power x is equal to a power b power c power d. Whatever height you can increase, They're all constant, nothing to worry. You're supposed to get dy by dx. Well, my dear, instead of using logarithmic differentiation, it is quite better to use the implicit function differentiation. That is, if you name this as some f of xy, what is the derivative of y with respect to x? dy by dx is equal to minus fx by fy. Come on, start. You think x as the only variable, all the others are constants. What is the derivative? It is variable. X power k. What is the derivative? Y power x. You see, y is a constant in our mind. We are in the numerator. In the numerator, you are supposed to have fx, that is the partial derivative with respect to x only. So y is a constant. You imagine that as k power x. What is the derivative of k power x? K power x into log k. That is y power x into log y divided by fy. It means that the partial derivative of f with respect to y. Now, y is the variable and x is the constant. Come on. Constant power y. That is k power y, imagine. K power y. What is the derivative? K power y into log k plus x is the constant. Y power k. Y power k. What is the derivative? K into y power k minus. That is x into y power x minus 1. You look at that, how simple it is, how simple it is. It is made simple simply because of this format. Minus dou f by dou x by dou f by dou y. Like that, we can simplify.